Now try to expand fx equal to 1 plus x to the power m as an infinite series. Okay, so we try to expand fx equal to 1 plus x to the power m as an infinite series. So to expand this, first of all, we let us take fx 1 plus x to the power m. So you try to differentiate this, so we get m 1 plus x to the power m minus 1. Then we take f double dash x, so we get m into m minus 1 plus x to the power m minus 2. So we try to generalize this in term of n. So when we have 2, we have here 1. So if it is n, it will be n minus 1. So we get m minus 1, m minus 2, m minus 3, till m minus n minus 1. So n minus 1, I multiply minus, so we get n plus 1. In the same way, if it is 2, here we have 2. So if it is n, it will be m minus n. So we get 1 plus x to the power m minus n. Now if I put here 0, we get m minus 1, m minus 2, m minus 3, till m minus n plus 1. So we'll try to write the remainder in Cauchy form. So we have the remainder in Cauchy form as x to the power n by n minus 1 factorial, 1 minus theta to the power n minus 1 fn theta x. So this is xn by n minus 1 factorial. So I'm writing xn by n minus 1 factorial, 1 minus theta x. So they are combined. I'm combining afterwards. From here, I'll try to arrange this term, because we try to put here, we try to put the value here, 1 plus theta x. So I'll try to arrange in that way. So I get here 1 plus theta x to the power n minus 1, and here we get as 1 plus theta x to the power n minus 1. So how do we get this? So here we have this, we have here 1, we have this 1 plus theta x to the power m minus n. So this I can write as 1 plus theta x to the power m into 1 plus theta x to the power n minus n. Sorry, minus n. So this can be written as 1 plus theta x to the power m divided by 1 plus theta x to the power n. Okay, so we can write this. Then I'll multiply both sides with 1 plus theta x to the power 1 plus theta x, 1 plus theta x. But for this, I'll combine with this, and for this one, I'll combine with this. So if I combine this one, we get 1 plus theta x to the power m minus 1 divided by 1 plus theta x to the power n minus 1. So in this way, we are trying to combine this. So we get here 1 plus theta x to the power n minus 1 and 1 plus theta x to the power n minus 1. And 1 minus theta to the power n minus 1 I put together, so we get this. So this is the remainder in Cauchy form. Now we can see that fn means this exists for all value of x. Okay, so now it depends upon m. So m is a positive integer. M can be a positive integer. Okay, and fn exists for every value of x greater than minus 1. So this function is defined for all value of x greater than 1 when m is a negative integer or fraction also. Now we'll try to write this. So this is 1 plus x. We are trying to write in the finite series of this 1 plus x to the power m. So this is a Markov theorem in finite series, but we are writing in Cauchy form. So we get here 1 plus mx plus m into m minus 2 by 2 factorial x squared plus so on, plus m into m minus 1 to m minus n plus 2 divided by n minus 1 factorial x to the power n minus 1 plus rn. Now this we get here rn. Now case 1 says that if m is a positive integer. So let us take an example of when m is 3. Let us take one example when m is 3. So what we'll have here, 1 plus x to the power 3. So this I'm taking as fx. So if I differentiate this, I get nothing but 3 1 plus x, okay, square. Then if I differentiate this, I get nothing but 3 into 2, I get 6 1 plus x. Then if I differentiate again this one, I get nothing but 6. So if I write the Markov theorem for this, so we get fx equal to f of 0. So f of 0 will be 1, then plus x f dash 0, so we get here 3 plus x squared by 2 factorial, x squared by 2 factorial f double dash 0, so f double dash 0 is nothing but 6 plus x cubed by 3 factorial f theta x, or that way, so we get here nothing but 6. So if we simplify this, we get here 1 plus 3x plus x squared by 2 into 6 plus x cubed by 6 plus 6 into 6. So this and this cancel, so we get here 3. So we get here 1 plus 3x plus x squared, 3x squared plus x cubed. We get 1 plus 3x plus 3x squared plus x cubed. So in that way we are getting here. So here also, if we have, and we can see that if we differentiate more than 3 terms, it means here when we take m equal to 3, if we differentiate 4 times, it will become 0. So this quantity, if we differentiate 4 times, this function will be 0. So in the same way, if we differentiate 5th time, also will be 0. So all the higher power will be 0. So if m is positive integer, the expansion ends after m plus 1 term. So we have seen also as an example that it will end after the m plus 1 term. So it will have only m plus 1 terms. So because of the factor, this thing is also tending, this will also make it 0. So we have that it will be till m plus 1 term. All the m plus 2, m plus 3 terms will be 0, as I have shown an example here. So we get here 1 plus x to the power m, 1 plus mx plus m n into m minus 1 by 2 factor x squared plus so on x to the power m. So here also, when we take the 3 factor here, when we have taken m to be 3, we get the answer as, here we have x cubed only. So when we are having only x cubed. When we take 3, m equal to 3, we got here x cubed. So when we take m equal to m, then we get x to the power m. So here, that why we are getting x to the power m. So this is valid for every value of x. Okay, now we'll take m to be any real number, not necessarily a positive integer. Okay, it can be negative, it can be fraction. So we'll take the Cauchy remainder form. We'll try to show that the Cauchy remainder form will tends to 0. So we are taking x lying between minus 1 and 1. So we are taking that way. So we'll try to show that this remainder tends to 0 as n tends to infinity. So this, we can see this is finite, so it will not depend on anything. So we have here x to the power n, So I have also said before in the previous video also that x to the power n will tends to 0 only for those value of x lying between minus 1 and 1. So other value which is lying, for other value of x which is lying above, we cannot say that this tends to 0. Since x is lying between minus 1 and 1, this value will tends to 0 as n tends to infinity. And this quantity is finite, so this is less than equal to 1, so it is bounded. If 1 minus theta by 1 plus theta to the power n minus 1 is bounded. So if you have see the Cauchy remainder here, so this is your Cauchy remainder. So this tends to 0 as n tends to infinity, and this is finite, and this is bounded. So this all are finite, so 0 into some finite number will be also 0. So the remainder will tends to 0 as n tends to infinity. So here we get this remainder tends to 0 as n tends to infinity. So by using the Mulcairn theorem for infinite series, we get here as 1 plus mx plus m minus 1 by 2 factor x squared plus so on m into m minus 1 minus m minus n plus 1 divided by n factor x to the power n plus so on. So So this series fx equal to 1 plus x to the power m converges only for mod of x less than 1. So it's valid when mod of x is less than 1. So we cannot say when the value of x is greater than or means if the value of x is lying between minus 1 to 1, it converges. But we cannot say if it is smaller than minus 1 or bigger than minus 1. So this function fx equal to 1 plus x to the power m converges only for values lying between minus 1 to 1. Thank you.